do we identify redox and non-redox reaction? The very first question we have here says, which of the following is not a redox reaction? This is a UTME question 1982, question number 13. So these are UTME questions, exam questions I have here, which we are going to be, solving, one by one. First of all, how do we identify redox reactions and how do we identify non-redox reaction? In the previous video, I talked about redox versus non-redox reaction. Please endeavor to watch that video for, a better understanding. All right, you should have watched that video before watching this particular video. All right, so I've equally done a separate video for oxidation number calculation. All right, endeavor to watch those videos. It's really going to help you to have a good understanding of this particular lecture video. All right, let's get started. Now, how do we identify redox? How do we identify non-redox reaction? Now, simple trick I'm going to give you. You're not going to get this anywhere else. Now, one thing you need to know is this. When you see a particular reaction, check if there is no element in the free state. If there is no element in the free state, I repeat, if there is no element in the free state, it tells you that that reaction is going to be a non-redox reaction if there is no element in the free state. That is to say, when you take a look at the equations, the reactions, and you cannot find any element in the free state, it tells you that that reaction is a non-redox reaction. But conversely, if you take a look, when you take a look at a particular reaction and you can see element in the free state, you can see one or two elements in the free state, come on, it tells you that that reaction is going to be a redox reaction. So that is the simple trick to identify redox and non-redox reaction. I believe you got that. Now, you must be knowing, now in the previous video, I talked about redox and non-redox reaction. I emphasize the fact that redox and non-redox reactions are based on the what? Transfer of electrons. That is to say, on the basis of transfer of electrons, there are two types of what? Chemical reactions. So redox and non-redox what? Reaction. Now, for redox reaction, there is going to be transfer of electrons, which will consequently lead to a change in the oxidation number. Okay, but for a non-redox reaction, there's no transfer of electron, hence there is not going to be what? A change in the oxidation number. So just for a quick recap on that, is sodium is going to lose an electron. Okay, it's going to transfer an electron. Sodium is going to transfer an electron. When sodium reacts with chlorine, sodium is going to transfer an electron to chlorine. So it's going to lose an electron. So chlorine is going to gain an electron to become negatively charged. Sodium is going to lose an electron to become what? Positively what? Charged. So at the end of the day, we will now have what? Sodium chloride formed. So sodium ion and chloride ion come together to give rise to what? Sodium what? Chloride. Okay. So this is as a result of the fact that sodium is the one transferring the electron. So if you want to write this in the chemical equation, you just simply say sodium plus chlorine giving us what? Sodium chloride. So the oxidation number of sodium here is 0. The oxidation number of chlorine here is 0. The oxidation number of sodium here is what? +1. Chlorine is -1. Okay, -1. So you can see that from 0 to, you can see that there's a change in oxidation number. Now, you can see here there's a transfer of electron. Okay, sodium is the one transferring the electron, and chlorine is the one gaining the what? Electron. So because there's a transfer of electron, you can see that consequently lead to what? A change in the oxidation what? Number. Okay, so this is an example, a classical example of what? A redox reaction. Okay, a redox reaction. And another thing you can see here is that you see elements in the free state. Here they are not combined. So in a redox reaction, there is transfer of electron. That's one. Number two, there is what? A change in oxidation number. It is the transfer of electron that consequently lead to what? Change in the oxidation number. And you will also see that there is what? It is evident that you're going to see that an element, one or two elements will be in the free state. So these are the things you need to know about what? Redox reaction. Okay, for a non-redox reaction, conversely, you are going to see that in a non-redox reaction, no element in the free state. All the elements are in the combined state. So that is how we identify a non-redox reaction. In non-redox reaction, there's no transfer of electrons, and because of that, there is not going to be a change in the oxidation number. Okay, so and about three things, the third thing you need to know is that all the species, all the elements involved are all in the combined state. Okay, that is a non-redox reaction. So let's see how we can apply these to these questions we have on the board. Okay, now the very first question we have here is UTME 1982 question number 13. It says, which of the following is not a redox reaction? So based on what I've said so far, if you take a look at option A, is it a redox reaction? You don't need to think, because I know you are not dumb. When you take a look at this is iodine. Iodine is in the free state. So this is what? This is a redox reaction, because you can see that there's an element in the free state, isn't it? Okay, I go again. I'm just going to be scanning through. I'm just going to be, okay, you take a look at this. Element in the free state, element in the free state. You take a look at this. There is no element in the free state here. So this is a non-redox reaction. If you come here, there is what? An element in the free state, oxygen here. If you come here, there's an element in the free state. So the only option here, the only reaction here that is not a redox reaction is what? Option C. So option C is the answer to that. Okay, option C is the answer to that. So in option C, why do we say it's a non-redox reaction? I told you three things you need to know about non-redox reaction. Number one, in a non-redox reaction, the three things you need to know about non-redox reaction. Number one, in a non-redox reaction, there's no transfer of electron. Number two, because of that, there's not going to be a change in the oxidation number, okay, of the components involved. And number three, there is no element in the free state, okay, for a non-redox reaction. Let's see. When you come here, calcium is +2 here. Let's calculate for the oxidation number. Remember I said I've done a video on the oxidation number. Okay, you can watch the video for a better understanding. Now, if you come here, you calculate for the oxidation number of calcium here is +2. Oxidation number of hydrogen here is +1. Carbon is what? +4. Oxygen is -2. If you come here, the same calcium that is +2 here will also be +2 here. The same carbon that is +4 here will also be +4 here. The same oxygen that is -2 here will be -2 here. You see that there is no change in the oxidation number of the component. Okay. Now, if you come here, hydrogen is +1, oxygen is -2. Carbon is +4, oxygen is -2. Is there any change in oxidation number? No. Calcium here is +2, calcium here is +2. Hydrogen here is +1, hydrogen here is +1. Carbon here is +4, carbon here is also +4. Oxygen here is -2, oxygen here is -2. You can see that there is no change in the oxidation number of the various components involved. Okay, there is no change in the oxidation number. So that is a non-redox reaction. Okay, you can easily identify it when you don't find any element in the free state. So a good example is this. So this is the answer to that. Now let's go to the next question. UTME 1989, question number 25. The question says, which of the reaction below is not an example of a redox reaction? Okay, when you take a look, come on, we have said it already. When you come here now, which of these is not a redox reaction? Come on, simply take a look at all of them, scan through them. Roman figure 1, I can see elements in the free state. Here, I can see elements in the free state. Sulfur is in the free state here. Here, nitrogen is in the free state. Oxygen is in the free state. Here, there is no element in the free state. So this is a non-redox reaction. So this is a non-redox what? Reaction. Non-redox reaction. So the only option here is which of the following reaction below is not an example of a redox reaction. So the reaction here that is not a redox reaction is option D. So option D, this Roman figure 4 only is not a redox reaction. Okay, because when you take a look, there is no element in the free state. Calcium here is +2, carbon is +4, oxygen is -2. Calcium here is +2, oxygen is -2, +4, -2. So you can see calcium here is +2, and the reactant side is +2. On the product side is also what? +2. Carbon is +4. Carbon is +4 here. Oxygen is -2 here. Oxygen is -2 here. You can see that there is no change in oxidation number, okay, because there is no transfer of electrons, okay. That is the non-redox reaction here. All right. So that is that. So let's go to the next question. UTME 1986, question number 17. What does it say? It says, which of these represent a redox reaction? Okay, taking a look at the four options, option A, B, C, D. Now, just simply take a look. Which of these represent a redox reaction? Remember I told you a redox reaction, how do you identify them? Element in the free state tells you it's a redox reaction. Where do you have element in the free state here? This is the only option, so that is the answer. Simple way to identify redox reaction. You got that right? It's cool. So you can see here, all the elements are in the combined state. Here, all the elements are in the combined state. Here, all the elements are in the combined state. So this is the only reaction where you find at least two elements. Zinc here is 0. Oxidation number of zinc here is 0. You don't forget, we say element in the free state have oxidation number of 0. Here, hydrogen is +1, chlorine is -1. Here, zinc is +2, chlorine is -1. Here, hydrogen is what? 0, element in the free state. So you can see that zinc that is 0 here and zinc is +2 here. You can see that's a change in oxidation what? Number. You can see hydrogen is +1 here, hydrogen is 0 here. That is a change in oxidation number. Okay, so you can see that this is the only redox reaction here. So how do you easily identify that? Without doing this I am doing, you can easily just spot it by saying, oh, this is the only one that has element in the free state. So that is the simple way to identify redox reaction from non-redox reaction. Now coming to the last one, it says, which of the following is a redox reaction? Taking a look at this, the same principle, we are going to use the same rule, the same clue to identify this. Now, take a look at this. All of them element in the free element. There's no element in the free state here. Yeah, I've spotted this. There's element in the free state here. Here, bromine is 0, element in the free state. Here, bromine is going to be minus what? 1. Okay. Iron is going to be +3. Iron here is what? +2. Bromine here is what? -1. Okay. So you can see that there's a change in oxidation number. Bromine here from 0 to +3. So there's a change in oxidation number. So here, there's no element in the free state. Here, there's no element in the free state. So the correct answer to this question. This particular question was given JAM what year? 1985, question number 26. That was UTME. 1985, question number 26. That was a question that year. So we are done with this. So this is the easiest way to identify redox and non-redox reaction. All right, is Dr. Cliff. Bye for now.